Hello students, this is Sujatag coming with our channel class 10 NCERT SSC Maths with Sujata G. Welcome students in the new chapter 5th Arithmetic Progression. Students, in this chapter there are 4 topics. Topic number 1 Introduction, topic 2 Arithmetic Progression, third one is the n term of an AP, and the fourth one is the sum of first n terms of an AP. Let us student see the first topic, introduction. In nature we must have observed that many things, and that many things follow a certain pattern. We know about that. And suppose the example, we can take the example of these petals of a sunflower, the holes of a honeycomb, the grains of a maize-cob, the spirals on a pineapple, and on a pine cone, etc. etc. Such examples having the specific pattern, and we observe carefully. Now here some patterns which occur in our day-to-day life here also. So let us see the examples of these. First one example of Rina, that Rina applied for a job and got selected, and she has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of rupees 500 or so, and in her salary, and her salary for the first, second and third years will be respectively. That is, first month salary will be 8,000, second one 8,500, third one 9,100. So this way the salary is going on for the specific month. And here if you see that these are the terms, these are the number of salaries. So in the first month and the second month there is a difference between the salary is 500. The difference between the salaries in the second and third month is also the 500. So there is a specific pattern in the salary of Rina. Now the second example, the length of the rungs of a ladder decrease uniformly by 2 cm from bottom to top. Okay, so now here see the figure of this ladder and their rungs. So as from bottom to the top, the length of the rungs are decreases. So this way the rungs of the bottom decreases by here the 2 cm. See, this is the number of lists: 45, 43, 41, 39, 37, 35, 33 and 31. So these are the rungs of ladder respectively, one by one from bottom to top. And here we see there is a specific patterns arises, and that specific pattern is for between these two consecutive terms, the previous one, if you subtract from the previous number to 2, then we get the 43. If you subtract 2 from the previous number, then you get the succeeding number. Then this way, that if you subtracted 2 each preceding number, then you get the successive number. So this way there is a specific pattern in the rungs of the ladder. So now here in a saving scheme, the third example, that in a saving scheme the amount becomes 5/4 times of itself after every 3 years. The maturity amount in rupees of an investment of rupees 8,000 after 3, 6, 9 and 12 years will be respectively. That is the 10,000, 12,500, 15,625, 19,531.25. So this way, in these two consecutive terms, there are the specific difference, there are the fixed difference, and so we say that it is a specific pattern having this number of lists. Now here the fourth example also observe the number of unit squares in squares with side 1, 2, 3 units. See here the figure that the number of unit will be that square of 1, square of 2, square of 3. So this way, as the side increases, then the pattern will be arises, and that means there is a specific pattern. Now the fifth example, Shakila puts ₹100 into her daughter's money box when she was 1 year old and increased the amount by ₹50 every year. The amount of money in rupee in the box on the first, second, third, fourth birthday were 100, 150, 200, 250 respectively. So now here first amount is 100 and the amount will be increases by the 50 rupees. Here 150, adding 50 in the previous one, we get the successive number. So there is also the specific pattern. And the sixth one, that is a pair of rabbits are too young to produce in their first month. In the second and in every subsequent month, they produce a new pair. Each new pair of rabbits produce a new pair in their second month and in every subsequent month. So assuming that the rabbit do not dies, the number of pairs of rabbits at the start of the first, second, third, 6 month respectively are 1, 1, 2, 3, 5, 8. So here if you observe carefully, then these number of lists having also the specific pattern. Now this way we can see that the above examples, these such examples that we written here, that there is some pattern. So we can say that in some examples the succeeding terms are obtained by adding a fixed number, but other examples, some examples we say that by multiplying with a fixed number we get the another. So we find that they are a squares of consecutive number. So this way the we get the specific pattern in the specific number of list. So this way we can say that in this chapter we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms, and as well as we also have to find out their n term and the sum of the n consecutive terms and use this knowledge in solving some daily life problems. So now students, let us see the second topic, arithmetic progression. So now here see there are the list of number, some examples are given. First example is 1, 2, 3, 4. This is a list of numbers. But what is the specific pattern is here? The specific pattern is that each term is one more than the term preceding it. Okay, see the preceding number is 1. If you add 1 here, then we get the succeeding number. 2 plus 1, then get the another term, that is a succeeding term. Then the second example here, 100, 70, 40, 10. So here in the number of list, each term is 30 less than the preceding it. So there is a specific pattern. And in the third example, -3, -2, -1, 0. In this example, each term is obtained by adding 1 to the term preceding it. So there is a specific pattern. Now here the fourth one example, see, very easy, that is a 3, 3, 3, 3. Here all the terms in the list are 3, and that is each term is obtained by adding or subtracting 0 to the term preceding it. So now here there is also a specific pattern in the number of list. Also here the fifth example, minus 1.0, minus 1.5, minus 2.0, minus 2.5, and here we see each term is obtained by adding minus 0.5 to the term preceding it. So here in these 5 examples we observe that there is a specific pattern. Now see here, in such an example there are the numbers that each of the numbers in the list is called as a term. So here in this number of list, minus 1.0 is the first term, minus 1.5 is the second term, minus 2.0 is the third term, and the minus 2.5 is the fourth one term. So this way that each of the number in the list is called as a term. Now here see, so we get idea about what is the arithmetic progression, that there is some specific pattern arises in the arithmetic progression. Yes student, there are some specific pattern arises in the arithmetic progression, but which type of the pattern is included here. So let us see that the successive terms are obtained by adding a fixed number to the preceding term. Such a list of number is said to form an arithmetic progression. Now how can we define the arithmetic progression? That an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. And here the fixed term or fixed number is called the common difference of the AP, and that fixed number may be positive, negative or 0. So in generally we can say that the first term of an AP is A1, second term is represented by A2, and the end term of this AP represented by the AN. Then the common difference by D. Okay. So now here I call it as AP. So AP is the short form of the arithmetic progression. Okay. Now here AP becomes first term A1, second term A2, third term A3, and the last term AN. So we can write the AP as this way: A1, A2, A3, AN. Now here, so we can get the common difference is same, constant. So we get that A2 minus A1 is equal to A3 minus A2 is equal to AN minus 1 is equal to D. Okay. So this way we can get the succeeding number. Now this is exactly AP. Now here take the examples of AP. Okay. So here first example, the heights of some students of a school standing in a queue in the morning assembly are 147, 148, 149, 157. Now here see the students, the first term is 147. If you add the plus 1, we get the second term. Adding the plus 1 in the second term, we get the third term. So this way the common difference is 1, and so this is AP. Second example, the minimum temperatures. Some more examples of AP are: first, the heights of some students of a school standing in a queue in the morning assembly are 147, 148, 149, 157. So here see, these are the number of list. In this number of list, first term is 147, second term is 148, third term is 149. How do we get the second term and the third term? By adding the preceding number. Adding 1 in the preceding number, we get the successive number. So this way we get the AP. Now the second example, the minimum temperature in degree Celsius recorded for a week in the month of January in a city, arranged in ascending order are first minus 3.1, minus 3.0, minus 2.9, minus 2.8, minus 2.7, minus 2.6, minus 2.5. So now here see, there is a difference in between these two consecutive terms is constant, and that's why this example is for AP. Then here, third example, the balance money in rupees after paying 5% of the total loan of rupees 1000 every month is 950, 900, 850, 800, dot dot dot. Last term is the 50. So here also the common difference between the two consecutive terms is constant. It's same, and that's why this example is in AP. Fourth one, the cash prizes in rupees given by a school to the toppers of the classes 1 to 12 are respectively 200, 250, 300, 350, dot 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 750. Now here also there are the consecutive term, and in between the two consecutive term the common difference is 50. Here the difference between the 200 and 250, that is 50, 250 and 300, there is also 50. So that's why the common difference is same. So this example is in AP. See the next example. The total saving in rupees after every month for 10 months when rupees 50 are saved each month are 50, 100, 150, 200, 250, 300, 350, 400, 450 and 500. So here also the common difference between the two consecutive terms is 50, and that's why this example is in AP. Now students, see here that A plus D, A plus 2D, A plus 3D, comma, dot dot dot, that represents an arithmetic progression. Okay. So now here A is the first term and D is the common difference. So this is called the general form and AP. General form of an AP. So this way, if you want to find out the last term, then we can also get the formula. Now here there are the finite arithmetic progression also. So observe these examples, students. So first, second, third, fourth, fifth. In this example, these are the number of list, and in this example the last term is given. The last term is given, and so that's why we call this arithmetic progression as a finite arithmetic progression. And here that infinite arithmetic progression. So for that you observe these 5 examples, students. Here the last term is not given. The last term is not given, and that's why we say that this is infinite arithmetic progression. These examples are infinite arithmetic progression. Now we have to find out AP. So now to find out AP, that's why we may need to know the both first term A and the common difference D. Then we can form the arithmetic progression. Now here first, if example, if the first term A is 6 and the common difference D is 3, then we get the AP as 6, 9, 12, 15. How can we get that one? If you calculate by calculating by formula, then we get this AP. How can we calculate? Here A1 is equal to 6, A2 is equal to 9. We can say that A1 is equal to 6, then A2 is equal to A1 plus D. The formula becomes A2 is equal to A1 plus D, which is equal to 6 plus 3 is equal to 9. A3 is equal to A2 plus D, which is equal to 9 plus 3 is equal to 12, and A4 is equal to A3 plus D, which is equal to 12 plus 3 equal to 15. So this way we get the terms 6, 9, 12, 15, and we can write the AP as 6, 9, 12, 15. Okay students? Now the second example, if A is 6, D is minus 3, then the AP is 6, 3, 0, minus 3. So let us student calculate that from the AP. Is it check correct or not? Check it. Here A is equal to 0, D is equal to minus 3, then first term is 6, second term we calculate by the formula A1 plus D. So here A1 is 6 plus D is minus 3. So 6 minus 3, which is equal to 3. So we get the second term minus 3. 3. Then the third term A3 is equal to A2 plus D. Then A2 is 3 plus minus 3. So here 3 minus 3. So which is equal to 0. So third term is 0. And the last one, fourth term A3 plus D. So here A3 is 0. 0 plus minus 3, that means 0 minus 3 is equal to minus 3. So our terms are 6, 3, 0, minus 3. So here see the AP is 6, 3, 0, minus 3. So this way we get the AP. Okay students? Now here third example is when A is equal to minus 7, D is equal to minus 2, then AP is minus 7, minus 9, minus 11, minus 13, comma dot dot dot. Now calculate or form this AP. Here A is equal to minus 7, D is equal to minus 2. First here the first term, we write the first term. Third example, when A is equal to minus 7, D is equal to minus 2, then AP is minus 7, minus 9, minus 11, minus 13. So here student, A is equal to minus 7, D is equal to minus 2. Now calculate A1, that A do not calculate. There is A1 means first term, that first term is given, so minus 7. Now A2, calculate A2 by formula A1D, A1 plus D. So now here minus 7 plus minus 2. So that means 7 minus 2, which is equal to 5. Then calculate third term. Third term is here, okay students, here minus 7. So here minus 7 minus 2 and here minus 9. So now A3 is equal to A2 plus D. So A2 is equal to minus 9 plus minus 2, which is equal to minus 9 minus 2, which is equal to minus 11. So now here calculate the fourth term. So A3 plus D, which is equal to minus 11 plus or minus 2, which is equal to minus 11 minus 2, which is equal to minus 13. So we get the terms minus 7, minus 9, minus 11, minus 13. So our AP will be minus 7, minus 9, minus 11, minus 13. Okay. So this way we can calculate, we can form the AP. Now the fourth example, see the fourth example, when A is equal to 1 and D is equal to 0.1. So let us form the AP. So here first A is equal to 1.0, that means 1. So now D is equal to 0.1. First here A1 is equal to 1, A2 is equal to A1 plus D, So that is equal to 1 plus 0.1, which is equal to 1.1. Then A3 is equal to A2 plus D, which is equal to 1.1 plus 0.1, and that is equal to 1.2. Then A4 is equal to A3 plus D. A3 is equal to 1.2 plus 0.1, which is equal to 1.3. So this way we get the terms as 1, 1.1, 1.2, 1.3. So our AP is 1, 1.1, 1.2, 1.3. Okay. So this way we can form the AP, very easy process and very short process. Now here the fifth one example, students, when A is equal to 0 and D is equal to 1 integer 1 upon 2. So here form the AP here. So A is equal to 0, D is equal to 1 integer 1 upon 2. So now here that A1, I calculate here, A1 is equal to 0, A2 is equal to A2 is equal to A1 plus D. That means 0 plus D. D is 1 integer 1 upon 2. That means 3 upon 2. Okay. Then calculate A3. Formula is A2 plus D, which is equal to A2. A2 is 3 upon 2 plus then D. D is also 3 upon 2. So 3 upon 2, that 6 upon 2 is equal to 3. Okay. So this way we get formula here. Now here that the A4. We have to calculate A4. That means A3 plus D. Okay. So now here A3 plus D, that is equal to A3. A3 is equal to 3 plus D. D is the 1 integer 1 upon 2 and that is equal to 3 upon 2. So 3 plus 3 upon 2, that means 3 2s are 6, 6 plus 3 upon 2 and that means 9 upon 2. Okay. So this way we get the terms and this way the AP is 0, 3 upon 2, 3 and 9 upon 2. Now in the sixth example, see here A is equal to 2, D is equal to 0 and that means A1 is equal to 2, A2 is equal to A1 plus D, where A1 is 2, 2 plus 0 which is equal to 2. Now A3 is equal to A2 plus D which is equal to 2 plus 0, that means equal to 2. A4 is equal to A3 plus D. So student here always we get the value as 2. So here terms are 2, 2, 2. That means our AP is 2, 2, 2, dash, dash, dash. Okay. So as we know the first term and the common difference, then we can calculate the AP or we can form the AP. Now, and we know that every succeeding term is obtained by adding D to the preceding term and so be found by subtracting any term from its succeeding term. That is, the term which immediately follows it should be same for an AP. So this is the clue or this is the method to find out the AP. Students, thanks for watching our videos of 10th NCERT Maths. Keep watching our videos continuously. We're sure that you will get 100% success in maths. So like and subscribe our videos